Hi, Laura. Hi, Gus. All right. I am going to get started just so that you guys aren't just sitting around and wasting your time. We are going to do our geometric sequences and series today. It's going to pretty much feel a lot like our arithmetic um, sequences and series from last week. So today we'll introduce this. Wednesday will just be a review of this. I will not introduce anything else. And we'll finish up with the homework for this last week and this week. So Wednesday's just going to be a question and answer day. And Friday we'll leave up to how many questions and answers are necessary. So what you're looking at is out of order. There we go. We want to do a real quick review of our geometric sequences. So this does go back to what we did last Monday, where we were looking at how does the pattern increase, and it's going to increase with a common ratio, not our common difference like we do when we add. And I wanted to remind us of our formula that we used last week, and that was our whatever the last term is, so that's what that a to the n means. Our last term is equal to whatever the first term is times that ratio, that common ratio, raised to a power where it's however many places minus 1. So what we're looking at is trying to just review that stuff from last week. Hi guys. Sorry about the delay. Had the hover cam, of course, wouldn't work, so I had to restart the computer and everything. So I took this example where we have a meme that wants to tag 4 friends and then tells those 4 friends to tag 4 more friends and so on. So we've all seen that just recently, in fact, where it was 5 words, 5 tags on Twitter. So it's kind of the same idea here. And how far would that go? And it's interesting because when I saw that, when it was first posted early that one day, I saw 5 words, 5 tags. Of course, everybody jumped on board. And then all of a sudden, I started seeing people doing it from Amherst, from Lorain, from North Ridgeville. And I just thought it was pretty interesting to think, like, how far would that go and how many people got involved in that? So I kind of played around with that idea with this example. So we have where this person is the one who started it. And honestly, I think for us, maybe it was Coach Ladd. I don't know. But wants to send this meme to 4 of her friends. And then those 4 are going to 4 and so on and so on. So we've got this pattern, and it wants to know how many people will receive it by the 9th round. So we have our geometric sequence, and we know that what it started with was Lauren sending it to her 4 friends. So Lauren's the first position. What does she do? That's that output, that domain range type idea. We know every time this is going to happen, it's by 4. So our common ratio, they're telling us, is 4. The n is how many times are we going to have this in our sequence? Well, that tells us right here, n is 9. So when we plug all this information in, where is it at our 9th round? 4 times 4, and it just ends up being 9 minus 1. So we end up with 4 times 4 to the 8th power. Now, please make sure what you're very careful with here is, again, order of operations. You don't get carried away with multiplying everything too soon. And we end up with 4 times, now I did this ahead of time, And of course didn't write down what 4 to the 8th was, but that's 6, 5, 5, 3, 6. And what we find out is on that 9th round, we end up with 262,144 people would have received that email by the 9th round. Which obviously, when you consider why there are, and I just saw this on a show, why there are people who are making so much money being social media, that's their job for a company, is they do everything on social media. Think about how fast something can get out there if that's just 9. So what we're looking at is, again, using our information, plugging it into our formula, and moving on. So we did this last Monday. So again, I just wanted to kind of review where that came from. Now, we did also talk last Monday, and we looked at some no-re examples where we were just talking about how to deal with writing an equation. Now, we didn't actually specify that's what it was called, but we did try to figure out how would we determine our information if we had this sequence. So this time what we're looking at is, instead of guessing what R is or guessing how to do this, we're going to, again, rely on our formulas. So when we did all of this is very, it's a mirror image, honestly, of what we did last week, Wednesday, with our arithmetic series. So you're going to see the exact same kind of process and questions. This time, instead of a common difference, we're talking about our common ratio. So you're going to see the process is going to be almost identical. So we want to write an equation for the nth term of our geometric sequence. Now, in both cases, I used the examples that kind of gave us our sequence, and in this one, it just gave us information from our sequence. So with our first one, we have to figure out what that common ratio is. Don't forget, if you are looking for what that R value is, you always take the second, divide it by the previous, and we end up figuring out that that's -8. So the next term divided by the previous, and we figure out that's -8. So very quickly, we're able to find out what our common ratio is. So if I know that our common ratio is -8, we know our A sub 1 is that -0.25. If I just want to figure out what that nth term is, because we don't know where it's going to stop, we already have our formula. A sub n equals A sub 1 r to the n minus 1. Plug everything in. So we end up with A sub n equals -0.25 times -8 to the n minus 1. So if we're told figure out the 16th position, we'd plug 16 in here and we'd be able to figure out what that term is. So not a whole bunch of work here, but again, we're relying on our formula for this scenario. So now we look over here and we have to figure out what's our formula given this information. Well, they already tell us R. They already tell us the third position's value. And this down here is our n. What we have to remember is that's where n shows up. So when we plug everything into this formula that we're relying on, A sub n equals A sub 1 r to the n minus 1. We already know what a sub n is. For the n value, we have 16. And a sub 1, we already have r is 4, and we know that n is 3. So we end up with 16 equals a sub 1 times 4 squared. Well, we know that's going to be 16. So we find out a sub 1 is 1. So if we want to plug that back into our formula, we're going to have for a sub n, it's going to be 1 times 4 to the n minus 1. So we were able to solve for the first one, so that now if we didn't want to stop at a sub 3, if we didn't want to just go 3 positions, we wanted to go back out to 16 or 17 positions, now we have the formula that would hold. So in both cases, I'm just relying on the formula. Now, please keep in mind, all year we have talked about if there are formulas that you know you will not be able to memorize or won't use readily to have it memorized that easily, have them written down someplace where all you have to do is take out that big note card or that piece of cardstock or whatever so that you have that available just for these types of things. All right, so looks very similar to what we did on Monday last week, or on, Wednesday last week with our arithmetic parts. So one more that's going to look like what we did. Last week we talked about arithmetic means, and that was just a fancy name for those things that happened in between a sequence. They gave us a first term, they gave us the last term, but we didn't have those things in between. And depending upon how many there were, those were called our arithmetic means. Well, we've seen this term before, geometric mean. When we did it in geometry, there were only 2 terms. So we had one geometric mean between the 2 terms. So it does correlate. They're kind of the same meaning. In geometry, it was a segment, though, that we were referencing. But again, it still had the same purpose. It was that average between the 2 values. So with this, we're not just talking about one spot between 2 values. Now they're telling us how many we want, but that common ratio is still going to be there. So if we are looking for now, we want to find 4 geometric means between this. What that is we want, let's change that color up a little bit. We want our 1/2, but then we want 1, 2, 3, 4 numbers before we get to 512. So we want to look at, what do we have? Well, we still have our formula. So let's talk about this guy right there is our a sub 1. This guy right here is our a sub n. We want to figure out what n is. So I could count how many spots. There's 1 move, 2, 3, 4, 5. Or we could look that there's 1, 2, 3, 4, 5, 6, and plug in 6 for n. So in this case, we have our a sub n, which is 512, our a sub 1, which is 1/2. We don't know what r is, but we do know that we have 6 spots minus 1. That's where the 5 comes from. So 512 equals 1/2 r to the 5th. So eventually what we're going to be doing is taking the 5th root of something, which means we're going to have to use this. If I take 512 and divide it by half, it's going to be 1024. And when I do take the square root, or I should say, excuse me, the fifth root, I have to rely on my calculator for that. So just in case we don't remember, you have to push the number 5 first, and then the second button, and then this guy right here, the caret, because above it is that X. Now you can type in 1024, or you can push second answer, and that'll cut and paste it in for you. And what we end up with, ooh, I did the wrong one, so sorry. That's gonna 5. There we go. I was looking at my computer screen, not my calculator. 1024, and we end up with the number 4. That's better. So the fifth root, and we end up with 4. So R equals 4. So now we know what our common ratio is. So every time we come back to this guy, we're going to multiply everything by 4. So a half times 4 is 2. 2 times 4 is 8. 8 times 4 is 32. 32 times 4 is 128. So when we do list what they are, you would put that the geometric means are 2, 8, 32, and 128. So I'll say it again, just like what we did on Wednesday with our arithmetic means. All right, so if the pattern follows, after we did some of our review with our arithmetic sequences, we introduced the arithmetic series. And remember, series means that we're going to add everything up. So that's what we're going to do here with our geometric series. Now, I may or may not have alluded to this on Wednesday, but the arithmetic series had 2 different formulas. Didn't really matter. You could use the one, and it was pretty straightforward every time, and you could use it and solve for missing pieces, but it worked every time. I will tell you that these 2 are going to be necessary because it's a little bit easier than having to undo. So this time I would suggest having these 2 formulas in front of you. Not gonna lie, I will have them in front of me. If you're given the first term and how many are in the series, this is the easier one to use. If you're given the first term and the last term, this is the easier one to use. So keep that in mind. It just will make life a lot easier for you. So needless to say, I have my list of formulas. These 2 will be on them. I've done a pretty good job of memorizing the other ones, but the sum, the series, the partial sum formulas, those will be on my note cards. And you heard me just now say partial sum. Keep in mind that that's what they refer to these as, both arithmetic and geometric. Because again, it's not that we would know, especially if it was an infinite sequence, you would have only the partial sum from this term, from the first term to the 12th term, or from the first term to the 9th term. So here are the 2 formulas. We're going to use those. And what I'm going to do is go back to that first example. So I told you it was interesting to me about 5 words, 5 tags, and truly how many total people got involved in that. So I thought it was interesting with this 4 words to 4 friends. So let's just use that one for right now with one of these 2. And so if we go back to that first example where Lauren forwarded 4 memes to 4 friends and so on, we asked what was the value at the 9th round of forwards. So now what I want to know is how many total were there? So after Lauren forwarded it to her first 4 friends, then her first friends forwarded it to her 4 friends, and so on and so on. Now we could make a list, and you could start with 4 and then go to 16 and then 64, and every time keep multiplying by 4 until you get to that 9th round. And then you could take all those numbers and add them up. That could also serve the purpose. This formula will make it a little bit faster. So when we look at what we have, already we knew that we started with our 4. We knew that we were forwarding 4 every time, so our common ratio was 4. And then we talked about 9 rounds. So if we want to know how many total there were, we're going to go ahead and we're going to plug in our original 4. So a sub 1, our ratio was 4. And we're going to plug in the n to the 9th. And underneath, we have 1 minus r, which was 4. So 4 to the 9th is pretty big. So we end up with 4 minus 4 times. There's that number that appeared in our first example. And we're going to divide that by our -3. So now when I multiply that by 4, we end up with 4 minus 1,048,576 over -3. Well, that's going to be a negative number, obviously, on top. And we end up with negative 1,048,572 divided by -3. So the sum after 9 rounds reached a total of 349,524 people. A lot of people for just 9 times that was done. Many of you took part in that 5 words, 5 tags. So if we look at what that would have been, and I don't know where it started. I'm going to pretend that I think it started with Coach Ladd. So we'll assume that that was our first person 0. So we know that a sub 1 would have been that he tagged 5 people. And that every time there was going to be 5 tags. Anybody want to take a guess how many times that may have been forwarded? I would have absolutely no idea. And we're going to assume for right now, when we do this, that nobody got tagged twice, And if they did, they fixed that. I know I came in late to the game that day and had to fix that myself. So I'm thinking if we looked at just our school, how that went, maybe we talk about this got to 12 or 15 people. It's going to be a big number. So maybe on the 12th round. So that means N would be 12. So if we looked at how this would affect just that situation, S, the sum on the 12th round would be 5 minus 5. And then our rate, our common ratio, would look like that. So that's a ridiculously big number. And I will write it all out. And that's going to be times 5. So if I do this all in my calculator, I'm going to divide that by -4. And I find out that if it was only on the 12th round, the number of times just that happened now again, that's assuming that it went to all different people. And all those different people sent it to all different people. And everyone did that. Again, assuming nobody stopped and nobody was repeated. So that's kind of where we're at with our how fast this geometric increase can be. So again, looking at what we did last week, finishing up with arithmetic and geometric sequences and series this week. Wednesday will just be review of what you've been doing. I would take a look at what I add. It's only going to be one assignment this week, so keep that in mind. Let me know if you have any questions. I've been waiting for a couple more assignments to come in, so it looks like today and tomorrow you'll start to see again some updates in your grade book. And then I want you to, for those of you that are with me right now, think about how you want to approach the end of the year. I know there's been myself and probably Mr. Holohan, we've been discussing for you guys that are moving on next year to the CCP class, how much more you want from us. I know the May 22nd date was don't introduce any new material, just catch up with late work and answer any student questions, make sure grading is in, all that good stuff. Start thinking about what you want from me or us, as in, do you want us to stop, or do you want to keep going, or do you want to even do some sessions during the summer? That is entirely up to you guys. Obviously, I would be more than happy to help because I know that it could even be stuff that you want to review, that you want to talk about that we already did, that you want to kind of push forward. It's entirely your choice. But what I don't want is for you to feel that you're kind of left without an option. So just kind of keep that in mind. Please email me with any questions. So we will come back again on Wednesday just to see if you have anything that you want to go over with me. And again, always email me the questions ahead of time so I can have them written up and out to you before we meet. So hopefully you guys are all doing well, and hopefully I'll hear from someone soon. So talk to you guys next time.